Okay, now we have about 7 I think to go, and those are a bit more tedious, but not a big deal. What do you notice about this problem? Those are equal. So first things first, I need to use long division. That's a 1. That's x cubed plus x squared. Subtract 3x squared plus x minus 1. Divide again. That's... oh, actually, that's it. So this is the integral from 1 to 2 of 1 plus the remainder. 3x squared plus x minus 1 over x squared into x plus 1, all dx. So I'm going to go on the side and I want to figure out as quickly as possible where did I want to figure out as quickly as possible where did 3x squared plus x minus 1 over x squared into x plus 1 come from? Well, x squared and x plus 1. A, since this can be written as x times x, that's B, and a C. If I clear the fractions, I'm looking at 3x squared plus x minus 1 equaling ax plus b, ax into x plus 1 plus b into x plus 1 plus cx squared. And what values can I not have? I can't have x equals 0. Let x equal 0. That's gone, that's gone. Negative 1 equal. Put a 0 there, that's 0. Put a 0 there, that's b times 1, which is b. That's a 0. I got b. How do you like that trick? And I'm going to let x equal negative 1. Negative 1 squared, that's 1, that's 3. Minus 1 minus 1. A negative 1 in there will make that a 0. A negative in there will make that a 0. C, negative 1 squared will make that a 1. So that means C is actually a 1. I got C as well to be a 1. This is a 1, and this is a negative 1. Do you see here I don't have a third case? Well, if you chose 0 and negative 1, choose any other value of x in there and you'll get A and you're done. Stay away from 0 and negative 1. Let's say x equal 1. 3 plus 1 minus 1 is 3. A 1 for x, that will be A times 1 times 2. A 1 in there, that will be negative 2. And a 1 in there, that will be a 1. This will be 1 equal, that will be 3 equals 2a minus 1. So 2a equal a 4, a equal a 2. Hopefully I'm not making any mistakes. Otherwise the answers will be way off. I do have that worked out. Okay, so what does that mean? That means this is the integral from 1 to 2 of 1 plus 2 over x minus 1 over x squared plus 1 over x plus 1, all dx. That would be x plus twice natural log of x. I don't need the absolute value because x is between 1 and 2, but it doesn't. And this will be plus 1 over x, right? That's x to the negative 2, add 1 to the power, divide by that. Evaluated from 1 to 2. That would be 2 plus twice natural log of 2 plus 1/2 plus natural log of 3 minus, put a 1 in there, twice natural log of 1, that's a 0, plus 1 over 1 plus natural log of 2 again. On the homework you get me the exact answer. On the exam that's more than enough. So now we're getting into all the different exceptions. How about that problem? This is proper. This is x squared over x cubed. So I need to figure out where this came from, and let's do that. In this case, I'm trying to figure out if I look at 3x minus 5x squared divided by 3x minus 1 into x minus 1 squared. I would say 3x minus 1, x minus 1, x minus 1 squared. Linear A, linear B. I could write that as the product of linear factors. Clear the fractions. 3x minus 5x squared equals A into x minus 1 squared plus B into 3x minus 1 into x minus 1 plus C into 3x minus 1. And I could find two of those. Let x equal 1/3 right there. 1/3, that will give you a 1 minus 5/9. A 1/3 right there. 1/3 minus 1 is negative 2/3. Squared is 4/9. A 1/3 there will make that a 0 and that a 0. Guess what? I got it. 1 minus 5/9 is 4/9 equal 8 times 4/9. That means A is 1. Let x equal 1, the second value you can't have. If you put a 1 in there and a 1 in there, 3 minus 5 is a negative 2. A 1 in there will make that a 0, C times a 1 in there. 3 minus 1 is 2. That means C is a negative 1. And if I let x equal, I chose 1/3 and 1. How about 0? I'll get 0 to equal. A 0 in there will make that negative 1 squared, which is 1. A 0 in there and a 0 in there. Negative 1 times negative 1 is 1 times B, that's B. And a 0 in there will make that a negative C, but I know C is a negative 1, so that's a positive 1. So that means B equals a negative 2. And there it is. That's really the hard part, the algebra. This is the integral of 1 over 3x minus 1 minus 2 over x minus 1 minus 1 over x minus 1 squared. Again, a warning. That is, so this is natural log of 3x minus 1. If you were taking a derivative, you multiply by 3. If you're integrating, you divide by 3. Twice natural log of x minus 1. A warning about this. This is not natural log. This is 1 over x minus 1. It's really x minus 1 to the negative 2. Add 1 to the power, divide by that. Evaluate it from 2 to 3. That is 1/3 natural log 9 minus 1 is 8 plus twice natural log 3 minus 1 is 2 plus 1/2 minus, put a 2 in there, 1/3 natural log 6 minus 1 is 5 plus twice natural log 2 minus 1 is 1, that's 0, plus 1 over 1, and there is my answer again. What if I get to problems that don't zero out? Like number 22. This is an improper fraction. I would use, oops, that's too high. I would use long division. I will take x to the 4th plus 9x squared plus x plus 2 and x squared plus 9. That gives me x squared plus 9x squared. Subtract, cancel out, x plus 2. This would be the integral of x squared plus x plus 2 over x squared plus 9. That's not an equal, that's a plus. And if I really rewrite this, I could say that is the integral of x squared plus, and I could split this. This piece I know, that's x cubed over 3. This piece I know, that's 2 times, and we did memorize that the integral of dx over a squared plus x squared is 1 over a, the inverse tangent of x over a. Why did you learn that? Because it comes up a lot more than you like. That's 1/3 the inverse tangent of x over 3 plus c. The only thing left is this. If I look at the integral of x over x squared plus 9 dx, if I let u equal x squared plus 9, du is 2x dx. So this is the integral, that's a u, and this is a 1/2. So that is 1/2 natural log of u. Again, you don't need an absolute value on those because x squared plus 9 is always positive. And there it is. Few more to go. I want to tackle one of those. Let me check which one. Okay, let me get this one out of the way, number 28 first, see how that works. Well, I'm looking, this is a proper fraction. I'm trying to figure out where would x cubed plus 6x minus 2 over x squared into x squared plus 6 come from. Again, this is a lot more tedious than the traditional problems, but it's all good. We want to do all different kinds. This is A. Since I could write that as x times x, that's B. Since that cannot be written as a product of two factors, that's cx plus d. I need to find A, B, C, and D. In this case, if I clear the fractions, so notice our trick and the book's method are almost the same, except ours work if you could zero out one of those. And if you can't zero out any of them, like the next problem, then probably we're better off using either ours or the book. So let's see how this works. No matter what I'm going to do, I know that the domain x cannot be 0. I would let x equal 0. It would make my life a lot easier. Instead of finding 4 unknowns, I just find 3. 0, that will give me a negative 2. That's a 0. Put a 0 there, b times 6, and that's a 0. So that means b equals negative 1/3. Believe it or not, that's going to save you a lot of pain. Now here you have two options. Either you let x equal 1, negative 1, and 2, any three values to come up with 3 equations, 3 unknowns, or you stick with the book's trick. You say, you know what, let's use the book, and again, the book's trick is not that bad, it's just long. The book's trick is to get rid of all the parentheses. This is ax cubed plus 6ax minus 1/3 x squared minus 2 plus cx cubed plus dx squared. The book's trick, now that you found one of those, it's going to save the day. Get the cubes, get the squares, get the x's, and get the constants. The cubes would be a plus c, the squares would be simply negative 1/3. Oh no, the squares would be negative 1/3 plus d. The x's would be 6ax, and the constant is simply a negative 2. Well, negative 2 equal negative 2, that's easy. And look how nicely this works. A plus c, the number in front of the square, the cube must equal the number in front of the cube. That must be a 1. The number in front of the squared, there's no square, that means that must be a 0. That's the negative 1/3 plus d. Automatically, I know that d equals 1/3. And 6a must equal, the number in front of x must equal the number in front of x. That means a is simply 1. And if I put a 1 right there, doesn't that mean that c equals 0? So if I fill in the blanks, this is a 1, this is a 0, and d is a 1/3. I'll say this is 1 over x minus 1/3 over x squared plus 1/3 over x squared plus 6. Natural log of absolute value of x minus 1/3. When you integrate that, that becomes plus 1 over x plus 1/3. And again, this is the same integral we have just encountered. Where was it? A minute ago. What do you square to get 6? 1 over radical 6, the inverse tangent of x over radical 6 plus c will do the trick. Problem. I'd like to look at number 46. This is how I'm going to play with. The radicals are very hard to eliminate. Section 7.3 deals with radicals, but not even those. To deal with a radical, I let y equal u equal the radical. Now, if I take a derivative, this is going to be a big mess. I want to take a derivative and get a dx. How would that work? The only way that will work if I have an x on the right hand side, so I solve for x. This is advanced u sub. Square both sides. Still not enough. If I take a derivative now, I'll get 1 over twice the radical. I don't want that. Solve for x. And square both sides again. Now if I take a derivative, that is 2 into u squared minus 1 times 2u du. Well, fill in the blanks and don't lose track. This was my u. Dx is all of this mess. Dx would be 2 times 2. So that's 4. Times u into u squared minus 1. And x happened to be u squared minus 1 squared du. There it is. And if I look at this, this is actually, oh, I could cancel this with one of those, right? That's really u squared over u squared minus 1, isn't it? So if I do long division, that would be 1 plus 1 over u squared minus 1. If I look at 1 over u minus 1 into u plus 1, that is a over u minus 1 plus b over u plus 1. Clear the fractions. Let u equal 1, 1 equal 8 times 2, that is 1/2. And that's 0. Let u equal negative 1, 1 equal, that's a 0, b times negative 2, that's negative 1/2. So this is 4 times the integral of 1 plus 1/2 over u minus 1 minus 1/2 over u plus 1 du, of course. And that would equal 4 times u plus 1/2 natural log of u minus 1 minus 1/2 natural log of u plus 1 plus c. And that's going to be a 4. What was u? It's right there. The square root of 1 plus radical x plus 1/2 natural log of absolute value of the square root of 1 plus radical x minus 1 minus 1/2 natural log of the absolute value square root of 1 plus radical x plus 1 plus c. You could distribute the 4 in, you could leave it up front, it makes no difference. And number 50, I just want to show you, if I want this to be my du, what should u equal? What do you take a derivative of to get e to the x? Isn't that e to the x? That's how you're going to start thinking about this. Du is e to the x dx. Just be cautious. I colored the wrong thing. That's du. So get that out of the way. And wouldn't that be u minus 2? And isn't that u squared plus 1? So go on the side, 1 over u minus 2 into u squared plus 1. That would be a over u minus 2 plus b u plus c over u squared plus 1. Find a, b, and c and wrap it up. And there's your homework. And that concludes this section for us.